This is the AI News Flash for July 13th, 7 a.m. UTC. First up, researchers at China's Peking University have unveiled an optical chip technique that speeds up AI distributed inference more than 100. The all-optical interconnect system links standard electronic chips together using light, and the work was published today in the journal National Science Review. At its heart is a silicon photonic transceiver chip operating at 400 gigabits per second, converting electrical signals to light and back. The team claims it boosts distributed inference speed by over 100 times while using just 1/9, roughly 11%, of the typical compute resources. The researchers point to applications in autonomous driving and data centers as the power and bandwidth walls of AI data centers deepen. The optical links that connect GPU to GPU are becoming a critical focus in the US-China chip race. Next, Lenovo has denied allegations that it put banned Chinese SSDs into laptops where they are not allowed. The review site Notebook Check reported finding a solid-state drive made by Chinese manufacturer YMTC inside one of Lenovo's ThinkBook laptops. YMTC was banned from the U.S. market on national security grounds under a Biden administration decision. Lenovo investigated and said the laptop in question was not sold into the U.S. market, but was a model destined for Germany and therefore did not constitute a violation. The backdrop is an acute shortage of memory and storage driven by the AI boom. With inventory tight at leading suppliers, Samsung, Micron, and SK Hynix, Apple is reportedly asking the Trump administration to reconsider the ban on YMTC to help it find the parts it needs. Finally, a University of Michigan research team has unveiled NeuroVFM, a generalist AI foundation model for brain imaging. It was trained purely on uncurated clinical MRI and CT scans without pairing them to radiology reports. The team used 5.24 million image volumes spanning over 2 decades of care, and the work was published in the journal Nature Medicine. It uses a self-supervised vision-only method called VolGPA that predicts representations in a latent space rather than reconstructing pixels. NeuroVFM outperformed all baselines across 156 diagnostic tasks and hit over 92% accuracy on clinical triage. Remarkably, it took fewer than 1,000 GPU hours to train, about 7 times faster than a leading baseline. The code has been released as open source and is expected to accelerate real-world use of medical AI. That's all for this AI News Flash.